people who know the proof of given two integers where b is bigger than 0, we know that there exists admit and move him. Yeah. There exists unique. Now, by now, everybody knows what all that means. There is my people.
Yes, sir.
There exists
A unique set.
Q R integers so that A equals BQ plus R. R is the remainder. If B is the divisor, R is less than B, isn't it? Remainder is less than the divisor. And the remainder can be 0. So this is the division theorem. And we proved it yesterday. It was a long proof. You understood the proof, didn't you? I sent you notes.
Yes. Yes, sir.
I sent you the notes. Good. Yesterday, to prove it, we used a set. I'm not going to go over the proof. We are done. I have other things to do. We did consider this set A minus BT, where A minus BT was bigger than or equal to 0 and T came from Z. Didn't we? Didn't we consider this set? You don't have to write it down.
Yes, we did.
Given B bigger than 0, we are dividing by. What is the process of division? Suppose you want to divide 23 by 5. 23 is 5 times 4 plus 3. Well, think of it this way. From 25, you subtract 1 5. Well, there is still lots of room. Subtract 2 5s. There is still room. Subtract 3 5s. Should we stop?
No.
Keep subtract 4. That gives you 20. Can we subtract one more?
Yes. No, not that. Yeah. No.
If we insist that all of these are bigger than or equal to 0,
Isn't it 5 times?
we cannot do that, right?
Yes, sir.
So you see, this 20, this number 20, this number 15, this number, what is this number?
10.
10. And what is this number?
5.
5. Oh, did I change this? How did I change this from 3 to 23, 23, 23, 23, and this becomes 3. These are the numbers that go into the set A. Do you understand?
Yes, sir.
You see the shape of why are we having A minus BT in there? Because that is really what is happening when you are doing the division. We ask how many times 5 goes into 23, isn't it? That's essentially what division is. How many times 5 goes into 23? So you come up with doing all these trials, the numbers you get, you put in there. There is a smallest number among them. That number is the remainder. Do you see that? The smallest number among this is the remainder. And this is another way of looking at it. The reason why we took A minus BT was, that's what we do when we try to do a division. 23 divided by 5 is 5 times 4. And see, and we, in our mind, we ask, 5 times 1. If I put 5 times 1, no. 5 times 2, 5 times 3, 5 times 4, 5 times 5, no, 5 times 4. So we are running through these numbers in our mind. The smallest among these is the remainder. A is not empty. A has a smallest element. We found that smallest element was this, and A equals BQ plus R, and we found that Q and R are unique, and that's the division theorem. Follow? We did that. Now, I'm going to make this smaller. Okay. Let us now continue. Well-ordering principle is a good tool in proofs. We saw that in the proof of the division theorem. Did we not? WOP, Atri.
Sir, we said we were going to use WOP for proof by counter positive.
Yeah, you see, proof. Those are methods of proof. This is a tool.
Okay.
We used that in proving that this set big A has a smallest element. Remember?
Yeah.
And that smallest element happened to be the remainder. Today we do something else. Do you know what is the, suppose we take 12 and 6. Suppose you take the number 12. What are the divisors of it? 1, 2, 3, 4, and 6. And the greatest among them, the biggest among them is?
Sir, don't we count 12 in it because we are counting 1?
We are counting 1. 1 is a divisor of 12.
Yeah, 12 is also the divisor of 12, right?
12 is also all. Let's look at the proper divisors of 12. Okay. So that means all divisors other than 12. Good point there. All divisors other than 12 are these. And there is the greatest one or biggest one is 6. We call the GCD, greatest common divisor of 12 and 6 is
6.
Greatest common divisor of 24 and what? 15.
3.
What is the great? What is it?
3.
3. It is the greatest one that divides both of them, isn't it?
Yes.
3 divides 1 divides 24. 24 has a lot of divisors. Wow. 15 has 1, 3, and 5. The common divisor is R1 and 3. So the biggest common divisor is 3. Greatest common divisor. So it is easy to find the greatest common divisor when you are given two small numbers. What if you are given two big numbers? How do you find the greatest common divisor? How does it look like? So that is what the next result is about.
Yes, sir.
So let theorem. The proof of this is easier than how to find the greatest common divisor of two integers. A and B are integers. Not both 0. Not both 0. What does that mean? We allow one of them to be 0, but not both of them. Agreed? If both
Yes,
of them
sir.
are 0, there is nothing to do. The greatest common divisor doesn't exist. Right? Because every number divides both of them, right? So the greatest common divisor is nonsense. So one of them has to be non-zero. All right. Not both 0. Well, then GCD of A and B exists and is unique. Not finished yet. Being, what about that GCD? It is the smallest or least natural number of the form ax plus by, where x and y are coming from z.
Sir, how could it be the least natural number? Isn't it the greatest?
Yes, that's very good observation. The greatest common divisor happens to be the smallest natural number of this form itself. Okay.
Oh,
Okay, that's amazing. That's amazing.
and how
We
could
will-
A or B be 0?
Well, if A is 0, then the let's take an example. A equals 0, B equals 12. What number divides both of them?
1.
1.
12.
What else? 12.
All the factors of 12 will implement to 0.
All the factors of 12.
All the factors of 12 are common divisors. Therefore, the biggest common
Yeah,
divisor
but if
happens
both
to be.
of them were 0, then all the factors in the world are divisors.
If both of them are 0, then every natural number is a divisor of both of them, isn't it? So these cases are not considered really.
Okay, sir.
Okay. So there is no problem. But if A and B are integers, we are not requiring any one of them to be greater than 0 or anything. Just not both 0. Then this is true. We can say more. This is going to be a beautiful theorem, very useful. Further, every common divisor of A and B divides GCDAB. The greatest common divisor is divisible by any common divisor of the two numbers. That is the theorem we are going to prove. And because you have already seen the proof of the division theorem, this is not going to be so difficult. Okay. We are given two numbers. Like before, we are going to construct a set A. Well, let's call it another set, S. This time, what we want are numbers like this. AX plus BY, X and Y are integers, and AX plus BY greater than 0. Don't be afraid of this. I am going to show that this set is not empty, therefore it has a smallest element. That smallest element happens to divide both A and B. Not only that, it is the biggest one, such biggest. That is beautiful. Luckily, the proof of this is not long like yesterday. We don't have to work that hard. I wrote here something. These elements look like this, don't they?
Yes.
I
Yes,
just
sir.
wrote down a set here. I say S is not empty because we said not both 0. So at least one of them is not 0, right? Then we have A times A plus B times B is a number of this form, isn't it?
Yes.
Choose X equals A, Y equals B. That will be A squared plus B squared. Now, since not both are 0, what can you say about, is this bigger than 0?
Yes, it is bigger than 0.
So we are saying that there exists a number of this form. There it is. And that is in the set S. So S is not empty. Follow?
Yes, sir.
We will pause here. This is the first step in the proof, showing that this set is not empty, because only then can we apply well-ordering principle. Is this set empty?
No.
Can you find an element that looks like this? For some X and some Y, you are free to choose from all over the integers. Well, I will choose A itself for X and B for Y. Then I get this. Wow, that is bigger than 0. That satisfies this condition. Therefore, you see, therefore, this element is in S, so S is not empty. Let me have a show of hands. If I get enough, I will go on to the next step. Otherwise, I will explain to you.
Sir, how come it took us so long to prove this with the division theorem?
How come it took us so long to prove the
Prove that the division theorem set was not empty.
the reason is That is the first time most of you saw such a proof. Follow?
Oh, okay. So that's
Now,
why you told us every criteria of it.
now you find that, hey, that is not hard.
Oh,
Because I
okay.
have seen this sort of thing before in the proof of the division theorem. All right. So do I go on to the next step?
Are we supposed to raise our hands if we understood?
Pardon?
Are we supposed to raise our hands if we understood?
Yeah, if you understood, raise your, if you agree that S is not empty, raise your hand.
Okay.
Sir, I
So I
didn't
have
understand.
5 people. Now,
Sir, I
some
have a
people
doubt.
here, they would raise their hand, but their picture is, I cannot see.
Sir,
Karnam.
Karnam has a doubt. Yeah,
Karnam, where is your hand?
No, sir,
he
I
has
did
a
not
doubt.
understand.
Do you understand? Do you agree with this?
No, sir, I have a doubt.
Do you agree that there is an element in there?
No, sir, but in ax plus by, we could have also taken some other number other than a and b instead
Sure.
of doing.
See, we don't need to. There can be others. All we need to is to find one. Will this qualify? Is this
Yes.
number in S?
Yes,
Why?
because x and y are integers and a and b are also integers, so we can write it like this.
This number is here because this number is bigger than 0, like they want. Follow?
Yes, sir.
Not all of these will be in there. Only those that are bigger than 0. Since S is not empty, well ordering principle implies S has a least element. And we will call that least element B this time, not remainder, because we are talking about divisor. Let's call it small d. Okay? Now we will go to the next page. If that is D, so we started with an A, we started with a B, we now got a D. D is the smallest element, least element of S, where S is AX plus BY, AX plus BY bigger than 0. That's what we have done so far. Okay, you guys can take your hands down. All right. So we have a D now. We have an A. Wait a minute. This D is bigger than 0, is it?
Yes.
Why is this D bigger than 0?
Sir, because AX plus BY is greater than 0.
Why is D bigger? Why am I saying D is bigger than 0? Because D is although it is the smallest element of S, it is still an element of S, and therefore it has to be bigger than 0. Follow?
Yes, sir. Sir, can you define what D is again?
What is D? Because we found that S is not empty, it has a smallest element by the well-ordering principle. That smallest element is what we call D. Question was, is that smallest element still bigger than 0? I say it is. The reason I am saying is, who can tell me why D is bigger than 0? Arjun? Arjun?
He had
Not
his
sure.
hand raised from earlier, I think.
Yeah, the internet problem. Who can answer why D is bigger than 0?
Sir, because D is the least element of the set
European,
S.
yeah?
D is though D is a least element, it is an element of set S, and we have defined set S to be the elements of set S to be greater than 0. So D should also be greater than 0.
That's it. Every element of D, every element of S is of this form that are greater than 0. And D is one of them, although it is the smallest. Therefore, D is bigger than 0. That is the answer. So I will take that away. So we have found if D is bigger than 0, hold it. Then we can apply A, B. D bigger than 0. Think of D as B. A is then some D times Q plus R, where R is less than D, bigger than or equal to 0. Am I justified in writing like this? Where did this come from? If D is bigger than 0, and A may not be bigger than 0, but it is not 0, let us say. If A is not 0, then we can write, even if A is 0, we can write it like that. What theorem is this? What allows us to write A like this? Did you learn that theorem in the last class?
The
Given
division theorem.
A,
Oh yeah, that is the division theorem.
this is the division theorem. If you have an A and a B, and B is bigger than 0, then we have A equals BQ plus R. Here, instead of B, you use D. So A equals BQ plus R.
Sure, but why did you write A equals DQ plus R?
Well, we
The
will.
smallest element. So
This is, we are going to. Well, this is something we would need. You will see shortly why I wrote it like that. The question is, is this allowed? Is this expression true? Does there exist a Q and a R so that you can write A as BQ plus R? We told you yesterday, if you have an A with a B bigger than R, there exists unique QR, so that what? A equals BQ plus R. We spent the whole class proving this yesterday. Here is a situation like that. A and a B, which is bigger than 0. So I can apply that. A equals BQ plus R. Don't confuse with this B. There I had R was bigger, less than B, greater than or equal to 0. So here D takes the place of B. So this is the thing. If you are agreeable, raise your hand. If you approve this step, raise your hand. 4 people. At 3. You have a doubt.
yes, sir, I don't really get what you have written on this slide.
What I'm going to do, you may not get yet. Why I wrote? Am I justified in writing this? That's what I am asking.
Uh,
What? am I justified in writing like this? Is there a Q and an R?
You can try to divide A by D. Okay, if you try to divide A by D, then this is what you get.
Yeah,
Okay.
but that is true. But I am saying there exists implies there exists unique Q and R, so that because I am applying the division theorem. Follow?
Yes, sir.
The division theorem gives us this. You guys can take your hands. 7 people raise your hand. Good. I could just write the proof in 3 minutes and be done with it, but that will not be communicating the proof to you. So we are happy with this. Now, we are going to prove that R is 0, in fact. If R is 0, what would that mean? If
The number is completely divisible.
that will mean that this D will divide A, wouldn't it? If I can prove that this R equals 0, that would mean that this D, that's the smallest element here, that D divides A. Similarly, I can find that D divides B. So D is a common divisor. And then it is very easy to prove that it's the biggest one. So let me show you. Claim R equals 0. This is beautiful. I am only claiming it. I haven't proved it. So suppose proof by contradiction. So assume R is not 0. That means R is less than D, bigger than 0. That means that R, which is not 0, is A minus DQ from here. But what is A minus DQ? It is A minus ASR. Very interesting. The least element, I am going to write it as A times something plus B times, well, I shouldn't use A times U plus B times V. A times U. The least element has to look like A times something plus B times something. What is that something? I don't know. I call it U and V. These are values of X and Y. So that's how D actually looks like. So I can substitute. Wait a minute, before I do. Atri, oh, you are gone.
Okay.
All my kids are gone. Atri is back. Atri, I can see you. Do you agree that the least element has to look like this?
Yeah.
So it has to be A times something plus B times something else. Agreed?
Yeah.
What is that something? I don't know. I call it A times U plus B times B.
That's a lot of variables.
Pardon?
That's a lot of variables.
Yeah, lot of variables.
But what if we get confused with the variables?
Well, this is actually a value. You
Oh.
see, x is a variable, y is a variable, u is a value of x, y is a particular value of y. Remember, this is the least element of s. So
Yeah,
it is a
these. Oh, okay. We did this for R last time, right?
yeah. This is like
Okay.
r last time. A
Yeah, D is the
particular
smallest
value of
element,
x
so
and
we
a
put these two. And then for R, sir, what is that calculation for R? You made a claim that R is equal to 0, and you're assuming that it's not 0.
yeah. See,
Okay.
I made a claim. I am trying to prove it.
Okay.
How do I? If we know if r is 0, then d will be a divisor of a, wouldn't it? A equals dq. A equals dq means b divides a, isn't it? If a equals dq, if if b divides a, it has to be a b times something. Agreed? So in particular, if a equals dq, d divides a. And that's one of the things we want.
Yeah, that's one of the things we want. That's what makes, that's how we simplify GC.
Yeah, we will see if we can prove that d divides a, d divides b, divides b. If d divides a, d divides b, and b is the biggest such divisor, we are done, isn't it?
Yeah.
We have to do.
If we prove that we're done,
If we prove these three things, we will be done. Then we will know that this is the largest divisor of common device, isn't it? We haven't done any of that stuff. We are, if r equals 0, then a equals dq, we would finish this. Follow? That's what I'm trying to do.
wait, no, I don't get it, sir. If if R is not 0, then this all will be true. But how is
if
our
r
work
is not,
done then?
wait a minute, if I am going to show that if I assume r not equal to 0, I am going to get a contradiction. So r has to be 0. I'm trying to prove that r equals 0. Are you with me?
Okay, but if we prove that D divides A and D divides B and D is the biggest divisor, then our work is done.
Then what is that D? That will be the greatest common divisor of A and B.
Oh, okay.
And that is what we are trying to prove.
Okay.
You see, A, B not both 0, a greatest common divisor exists. And this D is that
Yes,
one.
sir. But what about like how do you know that it divides B as well? Because
We
in
haven't.
the equation we only have A equals
Wait a
DQ
minute.
plus R.
You don't have to worry about this yet. That's a good question. We don't know if it divides B or anything. First, let us prove that it divides A, okay?
Okay.
Then we will show that D divides B. Then we will show that D is the biggest one. This is the hardest thing to do. In fact, it is easy because proof by contradiction. If D is this number, A minus BQ will be AU plus BV times Q. Do you agree?
Okay.
I'm using colors for you. Is this true? A minus dq, I substituted from here for d. So this now becomes A minus AU minus AUQ.
Sir, you can just cancel the A from both sides.
No, I cannot. I am removing the bracket. When I
Oh,
remove
okay.
this bracket, what do I get?
It becomes AUQ plus BVQ.
Plus,
But I think
Minus B.
BVQ.
do you agree? This step is correct.
Yes, sir. But why
But
do we
then,
have to do that? Instead, we could replace that minus D on the left side to
hold
minus
on, hold
AU
on,
plus
hold on,
BV.
hold on, hold on. This can be written as 1 minus UQ plus B times minus VQ. Huh.
This looks like AX plus BY.
Right. This looks like AX. Who said that? Johan?
Geometry.
This looks like AX plus BY. Wait a minute. This will be in big S if this is bigger than 0. Are you with me?
Yes, sir.
Yes.
But if we assume R is not 0, then R is here. That means R is bigger than 0. That means this is in S. Get it? If that is in S, no, this cannot be in S. D is the least element in S. R is less than D. Contradiction.
Oh, the
R,
exact same contradiction we got in the division theorem.
R is less than D. Contradiction. D
This is
is
the
the
exact
smallest
same
element of it.
contradiction we got in the division theorem as well, right?
Yeah, we used division theorem now. You see, we used division theorem here. If R is greater than 0, then we find that this R is in fact, because it is like this, it is in S. But look at this. We are assuming R less than D. That is a contradiction. Whoa. This is a beautiful proof, guys. One day when you teach this, you will appreciate, wow, this is a beautiful proof. Therefore, R equals 0. Therefore, we can say A equals DQ. Wow. Implies D divides A. Okay? Here is the proof of it. This D divides A. Anyone has understood that? If A equals DQ plus R, we found that R has to be 0. If it is not, there is a contradiction. If R is 0, A equals DQ, so D divides A. Done. We have done this part. You will find that the rest will fall out easily shortly. Let me go forward and come back. We found that A divides D. Similarly, we can, what divides D?
D divides C.
No. The other way. D divides A. Similarly, D divides B. Why? Because B is equal to some DQ plus R also. It may be different Q and R. Follow? B can be written like this too. Because you see, D is bigger than 0. Because D is contained in that set S. Therefore, we can apply division theorem and write like this. Agreed? Just like we applied division theorem to A, we can apply division theorem to B as well, because D is bigger than 0. And we will come to the conclusion that D divides B. Done. So D divides A, D divides B. D is a common divisor of A and B. Is it the greatest common divisor? Suppose M is a divisor of A and B. Then M equals some, I don't know, alpha, sorry. A equals some alpha M. B equals some beta M. Right? Is this true? If M is a common divisor of A and B, M times something is A. Is that true?
Alpha and beta, sir?
Beta, alpha and beta are some numbers. If
So what is
let's
the
say,
value? What is their value?
let me see. Let me give you an example. 4 divides 12. 3 divides, no, 4 divides, give me another one.
24.
4 divides 24, let us say. So this is my A, this is my B. 24 equals 6 times 4. 12 equals what times 4?
3 times 4.
3 times 4. I say this is like alpha M. This is like beta M. Get it? 4 divides 12 means 4. 12 is 4 times some beta. It turns out to be 3. Do you now agree with what I mean? I give you an example. 4 is a common divisor of 12 and 24. So 24 can be divided as alpha times 4. And it can be written as beta times 4. What is beta? 3. What is alpha? 4. It all depends on the numbers. If M divides A equals M times alpha. if m divides b, b is, can you have beta equals alpha? What happens if beta equals alpha?
Then A equals B.
Then A equals
Then A
B.
equals B. That's how come I chose a different symbol here. Is this clear?
I don't get it, sir. What are you
Okay,
trying
hold
to
on.
do?
Hold on.
Yeah, it will become clear once you like see the entire proof, Atri. I think Dr. T, you can just move on and show the
Hold on. B equals AU plus BV, but A is alpha M plus beta MV, which is M times alpha plus beta V. Therefore, M divides B. Whoa, we are done with this theorem. Tombstone. What did I just do quickly? If M is a common divisor of A and B, then this particular D that we were talking about, which is AU plus BV, you can replace A with alpha M times U plus beta M times V. You can factor out M, you get alpha U plus beta V. That is, D is a product of M and another number. That means M divides D. Therefore, D is the biggest. I think you guys go to school. You learn very, what do you learn in math in school? What do they teach you in school?
Not very complicated stuff.
Yeah, not very complicated stuff. They basically just repeat whatever they taught last year,
You
and
know,
then
next
they
time I come to
put,
India.
Yeah, that's exactly what they do.
exactly like
They
that.
repeat exactly what they did last year and then add one tiny thing.
Yeah,
Next time I come to India, probably September or something, I think I should talk to teachers. Yeah, it's not the fault of the teachers. It is the fault of our system.
yeah, school system.
System problem is called the systemic problem.
If we left it to the teachers, they will try to teach us more. But the
see,
system is telling them just teach this much.
You don't have to teach. It's not how much they teach you. It is what they teach you. But the problem is not with the teacher, is not the problem. The system is the problem.
Yeah,
Now, mind you, this is a problem in most countries. Okay.
with most
In
what?
most countries, this is a problem.
Oh,
Okay. Most countries, this is a problem. That is why they have camps like this for kids who want more. Wait a minute. Suppose we know that our D is the smallest element and it looks like AU plus BV. Agreed?
yeah.
Suppose, and we found that D divides A and we found that D divides B. Therefore, D is a common divisor.
Yeah.
That much we proved. Hey, wait a minute. Suppose M is a common divisor. What does that mean? A equals some alpha M. B equals some alpha M. No. What did I do? B equals some alpha M. Did I make a mistake?
So you should have put beta M in the second.
Yeah, if I put alpha M, it is like B equals A. That's a joke. So it should be a beta M. Follow?
Yeah.
This is what it means when you say M divides both A and B. Yes? This is what it means by saying M divides both A and B. I told you, if A equals 24 and B equals 12, and then 4 is a common divisor. And then 24 equals what times? 6 times 4. 12 equals 6 times 12. 24 equals 6 times alpha times 4. This is equal to beta times what?
It's supposed to be m times alpha and m times beta.
Yeah, wait a minute. It's 3 times 4. Beta times 4. So you see, the common divisor 4. If 24 divides 4, 24 is something times 4. Isn't that true?
Yes.
Isn't that true? If 24 divides 4, sorry, if 4 divides 24, 24 is something times 24.
So we just did this.
So that is how I wrote, why I wrote it. So let me erase. Oh, let's see. Go back. I'm going to erase all this junk here. Karnam, finally you raised your hand.
Yes, sir.
Yes,
I have a-
Karnam.
Yes, sir. I have a doubt that in that 24 and 12 example, we can also write alpha and beta as 2 and 1 because 24 is also equal to 2 into 12 and 12 is equal to 1 into 12. So then why did we write alpha 4 and beta 4?
But what I wrote, was that correct?
Yes, sir.
Was it correct?
It was correct.
If 4 divides 24, not if, 4 divides 12. In fact, 24 is 6 times 4. 12 is 3 times 4. It is like alpha m and beta m. That's what I wrote. Okay? There are other things you can say about this, but that is all we need. Because if that is true, then we can go back. What did we say? D is AU plus BV. That is alpha MU plus beta MV. That is M times alpha U plus beta V. This implies, what is the conclusion? If D equals M times something, what is it saying? M divides any common divisor divides another common divisor. That means that this is the greatest common divisor. D equals GCD, greatest common divisor.
But isn't D the smallest element in that set?
Yes, smallest element, yes. You might be the smallest person in your house by height, but you must be the smartest in your house. These are different things, different contexts. Are you with me?
Okay, sir. So
See,
yeah,
I
D is the
place,
biggest divisor.
see, in that set, D is the smallest. And that smallest guy is actually the greatest common divisor of A and B. Are you with me?
Yes, sir.
So the smallest there is not the smallest common. It's a good observation. How many people understood this proof? That the you are given A and B, not both 0, then you can find that D is equal to some AU plus some BV, and D is the greatest common divisor of A and B. We proved that by starting with this AX plus BY, where AX plus BY be greater than 0. Now S is not empty, we found, because A squared plus B squared is greater than 0, and that looks like A times B times B. Therefore, this is an element of S. So S is not empty. Therefore, by WOP, S has a least element. D. Now D, because it is here, is bigger than 0, and D is equal to some A times U plus B times B. We found that D divides A, D divides B, and if M divides A and M divides B, we found that M divides D. This implies that D equals GCD of A and B. Done. That's what we did. Let me go on. This has an enormous consequence. I want to reach a certain point. I have a theorem now. I'm sending you the notes so you read it and go over the steps again. Suppose you have two integers, A not equal to 0, B not equal to 0 integers. We are not saying they are positive. Suppose A equals BQ plus R, where Q and R are contained in Z. I don't like my Z. Okay. What does this say? What does this denote?
Integer.
These are the integers, positive, negative, and 0. Then watch this. A comma B is B comma R. I should say better. GCD of A and B is the GCD of B and R. I'm going to, if I denote GCD AB as AB, denote GCD AB as just AB for now. So we are saying that AB equals BR. So AB equals BR. This is very powerful. You will see between this class and the next class that this is very powerful theorem. It comes from the stuff we have done. Division theorem says that it is possible to write A equals BQ plus R if B is bigger than 0. So if they say A equals BQ plus R, well, that means that they are assuming B is bigger than 0. How is this? So let me, I think I like to push this proof through. I know you are struggling a bit probably. Too much proof. But guys, that's the real math. What did I say? Suppose.
Sir, I have a question.
Then A comma B equals B comma R. Greatest common. Oh, I didn't like that. Yes, question.
Yes, sir. How is the divisor equal to AX plus BY?
Say that again.
You wrote that the divisor is equal to AX plus BY. Why is that so?
Divisor is AX plus BY. Or you mean the divisor DV was AU plus BV?
Yes, sir.
Oh, we proved that in the last theorem. D was the smallest element of this set, AX plus BY. AX plus BY bigger than 0. The smallest element has to look like that too, doesn't it? If D is an element from this set, it looks like this.
No, sir.
So,
My question was, how do you know that D is of the form AU plus BV?
that's exactly what I answered. If D is an element of S, then D must look like this. Now, if D is given, see, X and Y are variables. As you change them, for example, let us take 4x plus 5y. Okay?
Yes.
Now, x and y are, you can have 4 times 1 plus 5 times 2, 4 times minus 1 plus 5 times 3. You can have all kinds of integers there. We are saying that this number D is A times, that means that this has to be fixed numbers. And I call those fixed numbers U and V. Okay, let us say, let us take what did we say? 24 and 15. A equals 24, B equals 15. Then what is the least greatest common divisor?
Three, sir.
What is the greatest common divisor?
3.
3. We are saying 3 equals 15 times something plus 24 times something. Whoa. I don't know what that is. Well, it may be. We are able to find that. In the next class, we will come up with a method that allows us to fill in this. That is called Euclidean algorithm.
Okay.
Now, it certainly is true that there is a certain number that goes there and a certain number. This is what, that is what U is. Are you with me? D
Yes, sir.
equals AU plus BB. Get it?
Yes, sir.
Yes,
That's
sir.
how come we called it AU plus BB. All right, let us. Okay, let us do this theorem. What time is it? I will finish this. So let AB equals A comma B equals B1, B comma R equals B2. I'm going to show that B1 divides B2. Then I'm going to show that B2 divides B1. That will show that B1 equals B2, and therefore AB equals BR, isn't it? Yes? If I can show that these guys divide each other, then they are equal, right? If you take two numbers, each of them divides the other. That means the numbers are the same. Agreed?
Yes, sir.
In fact, I'll give that to you as homework. Now, does D1 divide D2? Let's see now. We know that D1 divides A. This is a divisor. A comma B is the greatest common divisor. So D1 divides A and D1 divides B. Therefore, D1 divides BQ. Therefore, D1 divides B minus I. A minus BQ. But A minus BQ is R. D1 divides R. D1 divides B. Therefore, D1 is a common divisor. Therefore, D1 divides the greatest common divisor. Wow. I went fast here. Okay. This is in the notes. You figure out why from here, why I can go from here, why I can go from here to here.
From where to where, sir?
From this step, how come I can go to this? If a number divides a number, that same number will divide a multiple of that number. Agreed?
Yes, sir. That's obvious.
Well,
That's intuitive.
if D1 divides a number, two different numbers, it will divide the difference of the numbers too.
Yes, sir. Huh?
If A divides X and A divides Y, then A divides X minus Y.
Yeah, that works as well.
Okay.
Because it's
How
exactly
come,
the-
sir?
You can prove that too. I don't
we
know.
did this in the help sessions before Epsilon started.
Okay. So this is because, can somebody give a quick proof? But you prove it. Yes, Johan.
We actually done this. Why when you subtract two numbers that are different?
Yes. I want, so take that. So you can find that. Therefore, D1 divides A minus BQ. But what is A minus BQ? What is A minus BQ? R. So D1 divides R. But D2 is a divisor of R. So D1 divides D1 divides R, D1 divides B. Let me write it down. D1, thus D1 divides, D1 is a common divisor of B and R. D2 is the greatest common divisor. Therefore, D1 divides D2. Similarly, you can find that D2 divides D1. So this theorem is correct, proved. Let me quickly go to the next two. What does this mean? If somebody, this gives us the Euclidean algorithm. I have to do one of them because there is homework on it. Suppose somebody gives you two numbers, 232 and 136. Then we know that we can do this. 232 is 136 times 1 plus 1 times 96. Is that correct?
Yes, sir.
A equals BQ plus R. But we just proved that A comma B is B comma R. So let's see now. Let us take this B here. 136 equals 96. Divide it with 96. 96 times 1 plus 40. A equals A prime equals B prime Q prime plus R prime. Aha, A prime B prime is equal to Q prime R prime. Let me continue. 96 equals 40 times 2 plus 16. And I can take 40 and take 16 times 2 plus 8. Now I can take 16 and take it as 8 times 2 plus 0. When you get a 0, the number that sits before is the greatest common divisor of these. Oh, that is a Euclidean algorithm. So any number, we are going to be proving this, why this works. So if I give you a question to find the greatest common divisor of two numbers, what you do is you keep doing this. All right. And just before you get 0, that number you pick up is the greatest common divisor of these two. That will be proved in the next class. Why this is the greatest common divisor. This is the most famous. This is the oldest algorithm in the world. Over 2000 years old. Okay? The most famous, the oldest, very powerful. Given any two numbers, you can find the greatest common divisor using this. Okay, let me see what the time is. Time is up. Let me do. Give me two numbers, guys. Give me two numbers.
149 and 360.
149
077.
and 77.
Yes, sir.
77. 149 is 77 times 2 plus 5. That's an easy one. 77 equals 5 times what?
2.
15
No.
plus 2.
Yeah, 15. Sorry, my bad.
Okay. And 5 equals 2 times 2 plus
Plus
1.
1.
And 2 equals 2 times 1
1
plus
0.
3.
Oh, this guy. This is 1.
They're co-primes.
They're co-primes.
So you can find,
Yeah.
you can start doing Euclidean algorithm already, okay? Your homework will have several of these to find. And this is going to be very interesting. You guys are going to be going away from the camp a lot more powerful by way of your ability to apply. And we will show you how to solve equations like this. 12x plus if an orange costs 12 rupees and an apple costs 20 rupees and you have 280 rupees with you, how many apples, how many oranges and how many apples can you buy? You can find that using Euclidean algorithm. All kinds of stuff. Okay, very nice. Sorry guys, this I have to tell you that our discussion is often difficult, but we try to come back and forth, back and forth, back and forth quite a bit, and then you read the notes and it becomes clear. That's it. There is no
Yes, sir.
point in me giving you easy stuff like that. I don't want to do the school stuff here. Okay? School caters to the general public. So they are doing a job that is suitable for the general public. But for the mind that is interested in mathematics, they need to get the real stuff. Like Euclidean algorithm. Okie doke. Any quick question before we go?
No, sir.
Okay. So I'll see you tomorrow.
So just one question.
Yes.
So there's
When did Euclid find this algorithm?
It is not clear if Euclid found it, but Euclid did list it in his book Elements.
And when was that written?
Elements of Euclid by Sir Thomas Heath. Go and buy it on Amazon or someplace. If there is only one book in your house, this is the book. Aren't there some books in your house?
Yes, sir. There are many books in my house.
If a person like you live in that house, you should have this book, The Elements of Euclid. It's the geometry book. This is the most famous book in the world. This is the most important scientific book in the world because this ushered in the method, deductive method of mathematics. Tell
So
your parents to. Pardon?
was Euclid is a scientist also? Or just
Euclid was a mathematician. He
And-
proved several theorems. He also collected all the theorems known to his day and put it in a book, 13 little books. The 13 books of the elements. I don't know, in Greek, the translation of the Greek word is, in English, it is elements, like fundamental. So make sure you buy that book. It has all these geometry theorems. Like, if you take a triangle, and if the legs are equal, the angles opposite, the equal length legs are the same. This is called an isosceles triangle. Theorem. Anyway, see you tomorrow then.
Thank you, sir.
Thank you,
Thank you,
Bye,
sir.
Have a nice morning.
Bye, sir.
Thank you,
Hope
sir.
you
Bye.